Hello and welcome back. On the bench we have a vintage Simon game from 1978, still in the box. This unit was labeled as not working and I tried it a few years ago and it did not show any signs of life, and so back in the box it went until today. We're going to try and fix it. So the first thing that we want to do here is just take a quick look around. Have a lot of good graphics for a box of this age. It's still quite vibrant, the printing. 1978, Milton Bradley Electronics. It's Simon. Let's go ahead and take the lid off. And inside, our Simon game. Take this out of the box. Inside we have a couple of pieces of documentation, some instructions for how to play the various games. Apparently there are three different games built in with 4 different skill levels. So this kind of goes through that. We even still have the original warranty card. A little bit yellowed around the edges. I don't know if that is moisture damage or just yellowing from sunlight exposure. But this was never sent in. And a quick piece of additional information here, if I can get this out. Some instructions on what to do if the game doesn't turn on. Well, ours doesn't turn on, and I'm quite sure it's not the batteries. So let's take a look. Oh, and I guess an extra light bulb. So this uses regular screw-in type. This says 2.5 volts on it. So I don't think it's all the light bulbs that are burned out, because I think you would still hear some sort of a sound. But let's take a look at the Simon game. Okay, so here's the Simon unit itself. Quite large. I really have to say that the box is it's larger than any of the other board games or electronic games that I certainly have. I mean, dang, you could almost fit an Xbox in there. On the bottom of the unit, we have 2 battery compartments. The Simon takes 2 sets of batteries, which is rather bizarre by today's standards. It takes a 9-volt transistor battery, and this is almost certainly for the logic and the CPU inside of the Simon. And then another set of batteries, and I believe this is to run the lamps, because those are actually fairly power hungry, while the rest of the digital electronics are run off of the 9-volt. So before we attempt to put the batteries in, I'm just going to go ahead and test the batteries and make sure that the ones that I have are actually working. That is one of the things that it says to do in the instructions, so we might as well start there. I have some rechargeable batteries here, rechargeable 9-volt to rechargeable D-cell batteries. And if we get out the voltmeter, we'll go ahead and do a quick test. So we'll take one of our D-cell batteries. Okay, 1.3 volts, so just a little low, around 1.4. And this one is reading 1.4. So that should be sufficient. And we'll also test our 9-volt battery. Okay, 9.6. That seems just fine. Now, to get the Simon open, you actually have to pry open the battery doors, and I'm sure the instructions say possibly to use a small coin or a flathead screwdriver. I'm just going to use this metal spudger. So we'll carefully lift up the D-cell battery door and the 9-volt battery door. There we go. A little bit dusty, crusty on the inside there, and definitely a decent amount of battery corrosion here on this contact, so we'll definitely want to clean that up. This one's pretty clean, and the 9-volt connector looks fine. So we'll go ahead and pop some batteries in, although I'm sure with this corrosion here that this is probably not going to work, just like it didn't in the past. And we will connect our 9-volt battery and replace our battery covers. Okay. So if this was a working Simon, as soon as you turn it on, it would almost certainly start making some noise. But there is nothing going on. No combination of the switch positions, turning it on, turning it off, seems to have any effect. So I am not sure what's going on, but that's what we're going to find out. All right, so we're going to go ahead and take the batteries out. Next thing I want to do is just go ahead and clean up those battery contacts. So go ahead and remove our batteries. And for cleaning, we'll take a little bit of regular distilled vinegar. And we'll brush that on and see if we can get some of that green junk off of these copper contacts. It certainly looks like this is just regular copper for the contacts. We'll take our brush and tilt this slightly to the side, and that does give a way better view of that nasty corrosion. So we'll just start brushing this on. And that is already having a nice effect. And we'll go ahead and do this on this other battery contact, although this one is looking a lot better, but may still have some corrosion preventing good contact. And we'll just do this again on this contact here. Just try and get any of that nasty green junk off of this contact. And we'll probably use a little bit of sandpaper just to lightly sand the surface of this contact and see if that'll help clean that up a little bit. But I can already see some of the shine of the metal starting to come back through. I'm gonna let that sit for just a minute and we'll come back and clean it up. Okay, so the vinegar's been on these contacts for a couple of minutes. So we'll go ahead and dry this up and hopefully wipe away any of that remaining green junk. And wow, that has really cleaned up fantastically. I'm quite surprised with how well the vinegar has taken off that old battery junk. And I do see some more down here inside, so very likely once we open up this unit, we'll find some on the circuit board on the inside. You can see a little bit of that circuit board here. And we'll do the other thing on this contact. And while we're at it, go ahead and just clean up some of this. I'm not sure if it's corrosion or just dust, but it was a little bit crusty on the inside of the 9-volt compartment. Okay, with that taken care of, I think it's time to open this unit up. Okay, so there are 4 screws that hold the unit together. Before we remove those, we'll go ahead and take off our switch covers, and these just pop right off. So we'll put those to the side. Flip our unit back over and remove the screws. Okay, all 4 screws removed, and we'll flip our unit back over again. Actually, we'll keep it this way in case any of the buttons want to fall out. And this should just separate. Okay. So there we go. There is our actual Simon unit. So it's actually electronically pretty simple. It looks like it uses a TMS 1000 NLL chip as the CPU microcontroller. And then this chip here, which is almost certainly a driver to drive the high current for the lamps, and also likely for the speaker as well. Okay, next I think we'll go ahead and remove this. I'm not really sure what the purpose of this cover is here, but it's around the circuit board and is attached down here at the bottom. So we'll go ahead and loosen up these screws here. And that should let this piece kind of bend out of the way, like so. And yeah, just a piece of cardboard, not plastic or anything. And it gives us a better view of the Simon inside. So I think we'll go ahead and remove the remaining screws from the circuit board. I think we want to take a look at the bottom and see if there's any damage from that battery corrosion. And with that, the board should be free. There's a few wires for the speaker and the 9-volt connection. It looks like the D-cell batteries use these bent contacts, which appear to make contact on the bottom of the board. So here and here. And actually, our board looks like it's in pretty good shape. I do see some potentially loose solder contacts, so that really could be it. So we'll take a look at that. And we'll take some of our vinegar, and we'll use that to clean up these contacts here on the bottom of the circuit board. And we'll just go ahead and give that a good scrub, because there is some crust or corrosion just hanging around. We'll just dry that with a paper towel. And we'll move our circuit board out of the way for a moment. And let's see if we can tackle these contacts, which instantly, now that the unit is apart, those just come right off. So we have these battery contacts. And one of them looks pretty good. The other one, this is our one that had a good bit of damage. So you can see some pit marks and corrosion here in the copper. On the other side, it is quite bad still. So I think we'll take a little bit more of our vinegar and brush that on. Try and get some of this remaining corrosion off of this contact. And as you can see, it is definitely taking it off. The metal is still a little bit corroded looking, but it doesn't need to conduct a whole lot of current through these contacts. So if it's making any contact at all, it is probably fine. And still a little bit on this side. This vinegar is really doing a fantastic job of stopping this corrosion and getting the green crusties off of this metal. We'll just go ahead and do the same for our other contact. Even though this one was in better shape, it still can't hurt to just make sure that any of that corrosion is not going to cause any more damage than it already has. Okay, I'm just going to let that dry for a little bit, and then we will wipe off the rest of the corrosion. All right, so that's been drying for a couple of minutes, so I think we'll just go ahead and Just dry these off a little bit. The metal is still a little bit tarnished, but a lot of that is coming off on this paper towel, so we'll just keep wiping. Try and get any of that junk off. Okay, so I think we'll go ahead and put these back into the Simon. And I don't remember if these have a particular orientation. They both seem the same to me. So we'll go ahead and put one in like that, and the other one in like this. So yeah, you can see here where it makes that connection on the circuit board with this battery compartment. And I think I'll go ahead and put the batteries back in, at least in the D-cell compartment. And hopefully these contacts stay in place. Or I guess what we could do is reattach the board just temporarily. These two screws back in temporarily, just to hold everything in place. And interestingly, it looks like there is solder residue here on the top of the board. And this chip here, I'm not sure how well that's coming through, but it's actually not in the board all the way. It's at a slight angle. This side is a little bit more raised than this side over here. So just a manufacturing defect. Flip our unit over. And we'll pay attention to the orientation. So positive goes in this direction. And we will go ahead and put our battery door back on, so just at least these batteries are held in place. So with that, I think we can actually get the 9-volt, okay, yeah, the 9-volt connection. So let's give this a quick test. We will reconnect our 9-volt. And still no signs of life. Oh, it's doing something. What does that mean? Okay, I don't have the front on, so I kind of forget what the switches are. I think this is the power switch. Okay, so yeah, if we look at, yeah, so this switch all the way at the bottom, and if I turn, let me just turn this around. Okay, so the switch at the bottom is our power switch, and this is our game select, and this is our skill level. So I'm not really sure what failure mode it's in. The fact that we're seeing this light definitely means that the batteries here are making contact with the board, and I believe that means even this driver here. Oh! Okay. Okay. I don't know what any of that means. It kind of happened as I touched the side of this chip. Okay. Yeah, that is... Oh! This is definitely not behaving the way I would expect a Simon game to perform. So that's very strange. Okay. So I think we'll go ahead and disconnect our 9-volt battery. And I wanted to take a look at that contact that appeared to be loose on the underside of this board. So let's go ahead and get these two screws out. flip this back over. And let's take a good look at what that is connected to. So it definitely looks like there's a loose connection here on this switch, on the skill select switch, and some potentially dodgy looking connections here on, again, on the skill select switch. And I'm just looking to see if anything else seems weird. This seems to be, there's a little bit of flux residue here. I almost wonder if that has been reworked in the past. These wires are fairly loose, so I wonder if those are just not making good contact. But let's go ahead and heat up the soldering iron and see if we can go ahead and reflow some of those contacts, and hopefully that makes a difference. All right, our soldering iron is all ready to go. So let's go ahead and try reflowing some of these contacts, especially on this skill select switch, which definitely has a number of dodgy looking connections. Let's go ahead and apply some fresh solder. And we'll go ahead and break out the multimeter here, and we'll get this into continuity mode. We'll get the beep. And let's just test and make sure that these are making contact. So that looks good. That looks good. That looks good. And okay. So all of those are making good contact. I'm just looking over the board to see if I see any other contacts that look a little dodgy. And we'll go ahead and see if just putting this board back into place we'll go ahead and put our 2 screws back in. And these are necessary just so that we make good electrical contact with those battery terminals. Okay, let's try hooking up our 9-volt battery again and see if this is any different than it was before. Go ahead and power it on. Nothing. Okay, the next thing I want to do is I'm going to squirt a little bit of DeoxIT into these switches. This one still feels a little bit loose. The other ones seem well attached. But these 2 switches here have an extra metal contact on the side that actually gets soldered down for mechanical strength. This switch does not appear to have the same thing going on. Okay, so we have our can of DeoxIT, and we'll just lightly spray this. I don't want to get it all over the place. Oh, okay, I should have. That was strange. Okay, I suppose we should remove this battery first and turn it off, and we'll get a little bit of our DeoxIT into these switches. Work these back and forth a little bit. I do wonder if maybe spraying a little DeoxIT underneath these switch contacts here That may help a little bit. And get our DeoxIT and just spray lightly under these. And we'll just work these switches a little bit, try and work some of that DeoxIT into there. And dry up a little bit of this excess compound so it's not everywhere. Some microfiber cloth would have been a better choice here. Okay, let's reconnect our battery. Okay, well, it is still not working correctly. So I think we're going to have to take a deeper look at this circuit here, which is actually pretty simple. And to do that, we'll take a look at the datasheet, this TMS 1000. So this actually has an interesting history of being probably the first commercially available microcontroller, where it has a Harvard-based CPU and a mask ROM that was configurable by the factory. So, whoa, okay. Simon has a mind of its own over here. It sometimes does something and sometimes doesn't. So turn it off again. In any event, so yeah, the custom mask ROM, not programmable by the user. It was never really sold individually, so certainly not for hobbyist use, but I guess you could almost consider it the great-great-grandfather of things like the Arduino. If we take a look at the date codes on here, so this appears to be 1979, 19th week, and this chip, this SN7549, it is the 14th week of 79. So these two chips are from 1979, although the copyright on the outside of the box says 1978, so potentially a little bit later of a revision here, but still well over 45 years old. And for what it's worth, these all appear to be the original bulbs too. So I wonder if all of these do in fact work. We can test that in a little bit with our multimeter. But I think we're going to have to take a look at the data sheet to get an understanding of what all of these pins do. And potentially it's something as simple as a reset signal, or if it's using one of these capacitors here for some sort of an oscillator or timing, that potentially there is something wrong with that circuit, and so the chip is just not waking up and not executing code. So let's put this to the side for a minute, and we will take a little bit of a deeper look at the datasheet and the schematic for the Simon. Okay, so here we have the datasheet. Let's zoom in a little bit here. For the TMS 1000 series, as what TI describes it as, a one-chip microcomputer. So I guess for 1976, they weren't kidding, because this would have been a very advanced little system on a chip here, especially given the time. Okay, so here we have the TMS 1000, and it looks like there was a number of other variants in the same family. So probably very similar instruction set and very similar requirements. I believe we have the 28-pin version here, the TMS 1000, and it describes the read-only memory or ROM as being 1024 by 8 bits or 8192 bits, or 8K, more commonly referred. And then for the RAM, it's described as being 64 by 4 bits, 256 bits total, or 32 bytes of RAM. Wow, that is not a lot to work with, but I guess the Simon game is fairly simple. Looks like we have some voltage working requirements, so this is actually kind of interesting for a microcontroller to have rated voltages up in the 20 volt range. It looks like it's typically powered by 15 volts nominally at 68 milliwatt. Okay, so this is interesting. It actually kind of gives although this is the TMS 1200, we actually get a few reference circuits, so this might be useful later on. Okay, so here we have the pin assignments, and it doesn't exactly use a naming scheme that we're familiar with today, although there's a few things that I've been able to learn. Is that it has a number of outputs, it has a number of inputs, which are actually only 4 inputs total, labeled K1, 2, 4, and 8. And the rest of these are going to be used as outputs in some manner. So it has outputs and R, although I'm not really sure what the difference is between the R outputs and the O outputs. It appears to have 8 of each. Well, actually, no, it has more of these R outputs. So it actually has 10 R outputs, a total of 8 of the O outputs, and 4 inputs. And we do see that there is an oscillator connection over here, so very likely this is a good place to look at to see if we're getting any sort of oscillation out of whatever this circuit is that's connected here. So I was actually able to find also a schematic for the Simon. So thank you, Simon Inns. Oh, is that really someone's name, or is this a joke? In any event, here we actually see our TMS 1000 chip, and here is our 75494, which is really just being used as a driver for the lamps and also for the speaker. And it looks like this entire section is powered off of the 3 volts that come from the 2 D-cell batteries. And then this entire section is powered from the 9 volts that come in from the 9 volt battery. So here's our power switch, and that goes directly to VSS. And it looks like it goes through a capacitor to the init pin. And then here is our oscillator circuit, which also has a capacitor and a resistor. And then there is a diode here that is connected to VDD. I'm not really sure what the purpose of that is. That could just be another ground. But interesting here, we actually get a sense for the fact that it doesn't use any of these O pins. So these are just totally non-connected. The rest of these pins, these R pins, are used to multiplex the inputs. So it looks like it probably cycles through these different R inputs because all of the switches, so the green, red, yellow, and blue paddles, and then the skill select switch and the game select switch, these all share common points. And then on the other side, it has a wire that runs over here to this R side. So it must drive these individually and then look for some sort of a logic signal coming from the switches. So this gives us a lot of handy information to use, and I think we'll go back to the Simon and start doing a little bit of probing. We'll definitely start with our VSS, VDD, init, and also look at our oscillator, because those are some early likely candidates for why this is not working. Okay, I think I want to go ahead and just do a little bit of checking before we start looking at our chip. So we know that the battery terminals are connected this way. So if we take a look at that, we're getting 2.7 volts combined out of our two D-cell batteries. And this is our negative contact or ground on this side. And so I just want to take a look at what else this may be connected to on the board, just to find something to clip onto that's a little bit more convenient. Okay, I don't know why it does that. That is not, I don't know why it does that. Okay, so I'm going to take my alligator clip and just clip onto this battery terminal and the other one on the voltmeter. And then let's try probing. I mean, it's obviously doing something. That has to be coming from the CPU. That is a driven signal. It's running the speaker, and it's running this green, I believe this is, which is lamp number 1. And it is also switch number 1, according to the schematic. But if we look at the CPU, we should see the power coming in on pin 20. So we'll flip this a little bit. And counting from this side, so it goes 1 through 14 and then 15 to 28. So 15, 16, 17, 18, 19, 20. Okay, and we are seeing our 9 volts come in, and if we turn off the power and turn it back on, so there's our 9 volts. So we know it's at least getting that far. Did want to take a look at this diode here on the board and just make sure that that doesn't have some weird short. So I'm going to go back into diode mode. And let's see. This should allow power through one direction. Okay, and it does. So this diode is fine. And let's just make sure, I'm going to go ahead and switch this off. Let's just make sure that we don't have a weird short between our capacitors. No, that certainly seems okay. And that certainly seems okay. And we'll just test our resistors here. That seems okay. And that one also seems okay. Okay, let's take our voltmeter out of the way here, and I'm just going to use one of its probes, because what I want to test is if this driver chip is working like we expect. And based off of the schematic, it looks like this chip is always getting power from the two D-cell batteries, and that the power switch is only for connecting the 9 volt to the TMS chip. Okay, let's try connecting that to a logic high. We'll clip on to our other battery terminal, our positive side. We'll try that again. Oh, okay. So you hear that crackling, that's our speaker. So that's working. And we come back over here to pin number 5. And there's one of our lamps. So that's working. And if we come to pin 7, oh, there's another lamp. Interestingly, that has a very slow turn on time. I'm not sure why that is. It could be expecting a much higher signal coming from the TMS chip. Okay, so I think we see our driver chip is actually driving things. I mean, we're seeing this lamp over here and the Simon make noise intermittently. So I think the next thing we're going to want to do is break out the oscilloscope and see if we can see a clean signal on our oscillator. Okay, so I have the oscilloscope all ready to go. We have clipped on over here to our ground for our probe. And I think the first thing we're going to want to look at is this delayed init signal. And that is on pin 9 of the TMS chip. So if we count to pin 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's just turn it on and see what we see. Okay, so it briefly goes high and then it goes low. Let's do that again. So it goes high and then low. Okay, so now let's take a look at our oscillator signal, which we should see on pins 18 and 19. So if we count, we go from pin 1 to 14 and then 15 to 28. So 15, 16, 17, 18, okay. Looks like we're getting a frequency of 25-ish kilohertz, although it jumps around just a little bit. Let's see what we see here. Okay, we see that same... Oh, that's interesting. Looks like the scope probe influenced the clock a little bit there. Okay, well we are getting a clock signal on these pins, so it looks like the oscillator is working. That's good news. Next I want to take a look at the R outputs. So the R outputs are generally used for either multiplexing the different paths for the key switches and the game switches, and it's also used to communicate with this driver chip to drive the lamps in the speaker. But if we take a look at RO on pin 21, that is used for the game select switch. So let's take a look at pin 21. So 15, 16, 17, 18, and 19, those are our two clock signals. So 20 and 21. Okay, that appears to be high all the time. So that's pin 21, RO. Let's take a look at pin 22. Okay, that definitely looks like it's attempting to scan at around 550 hertz. But what's interesting is this signal appears to be high all of the time. So let's try manipulating our game switch. So I wonder if there's like a leakage somewhere, or this signal is just always high. Because in that case, I'm not sure that it will ever be able to read the other inputs. It is probably always getting a signal from this switch being in position, and probably thinking that we have one of these buttons permanently pressed. If we look at pin 21, no, pin 22, which is R1, we do see what looks like this attempt to scan or run through these outputs and read the inputs on the other side. Let's take a look at R2 on pin 23. Okay, so we're getting that same 550 hertz-ish signal. Okay, so we tested the TMS chip obviously in circuit with everything else. And we're seeing some weird signals come out on the R pins, which appear to be used to multiplex some of the inputs here. So what I want to go ahead and do is socket the TMS chip. And I figure while we're at it, we'll go ahead and socket this other chip alongside it, this driver chip. And then that'll give us a little bit better way to test the TMS chip out of circuit and also test the additional circuits that are still on the board and see if there's any weird short occurring on one of those R outputs crossed with one of the K inputs. So we're going to heat up the Hakko desoldering tool and get right to it. So first, before we desolder this with the tool, is I'm just going to go ahead and add some fresh solder to each one of these pins on the two chips. And next we'll take the Hakko and go ahead and start desoldering. Okay, all the pins desoldered here. So let's see if we can go ahead and lift these chips off. Normally you wouldn't want to just pry these, but I think since there's no solder on this side of the board, the risk is pretty low of pulling up any of the traces. And looks, we should just be able to pop these right off. Yep, here comes this chip. And we'll do the same for this one that's already a little bit bent up on this side. And that is lifting up just fine. Okay, there we go. And there's no markings on the board, but we'll just go ahead and mark the orientation of both of these chips. We'll just put a dot here. And that'll let us know where the little notch from the chip is oriented. So next thing, just to solder in our sockets. So we'll solder in this one here and this one here. And there's a lot of methods for attaching these sockets, but what I like to do is just get a little bit of solder on the tip. And we'll place our socket in the board. And making sure that you're not touching one of the pins on the side, but I like to just go ahead and tack down one side just with a little touch of solder. Then we go ahead and do the same thing on this pin here. And just use that opportunity to make sure that our socket is flush. And I'll go ahead and do the same thing for this other socket. So I'll just get a little bit of solder on the tip. And just make sure our notch matches our mark on the board. And I'll hold that there. Just a little touch of solder on this side. And another little touch on this side. And with that, I'm going to start down here at this opposite edge and just go ahead and solder the socket. And there we have our new sockets installed. Awesome. Okay, so we'll go ahead and reconnect our speaker wires. We'll just poke these through the board. That one doesn't want to go in. This one does. Flip this around a little bit. Go ahead and tack this wire down. And hopefully if we heat this pad up, the wire will go ahead and poke through. What's going on here? Okay, 2 speaker wires reconnected, so now we can flip the board back over. And, kind of lost the orientation there. Okay, so we have the board reattached. These 2 screws here just so that the 2 D-cell batteries will make connection to the bottom of the board, and the lamps and speaker will get power. I think next is we'll go ahead and reinstall our TMS chip into our new socket. And we'll go ahead and get our driver chip back in. Alright, so very unlikely that this will have fixed anything, but always worth testing any opportunity you get between steps. So we'll go ahead and reconnect our battery, power on. Huh. Does that mean it worked? Oh my goodness. Okay. I'm not really sure. It actually seems to be working. Well, I am a little bit confused. I've never seen this thing have even a semblance of working. I don't know if maybe there was a bridge somewhere on one of these chips, but it really does appear like it's working. Let's power it off and back on again, and we'll hit the start button. Keys seem a little bit fussy though. I don't know if that is just that the paddles hit these a little bit better, but... Okay, so I think to clean these buttons we'll take some rubbing alcohol, and for lack of anything better to use, because there is a little bit of a gap between the button and the contact that it makes contact with on the board, is I'm just going to take a little bit of paper and soak this in alcohol and use that as a mild abrasive, and use my metal spudger here to work that under the switch contacts. So let's do that. Okay, we'll just we fold some paper over our spudger here. I'll get that soaked in the alcohol. And we'll just run this under these contacts and see if this will loosen up or remove any weird residue that might have built up over the years. Okay, so these on the sides, those were definitely easy. These won't be so bad here. That middle switch, the game start button, that one's going to be definitely more difficult to get access to. Perhaps we can get in from this direction. Okay, I might have to use a different tool here. I'll use this tiny little screwdriver. Just want to get this worked in between the contact and the top of this switch. Okay. Let's see if this has had any effect. So I'm going to go ahead and reconnect battery and switch it on. Go ahead and hit start. It's immediately not working. Oops. Okay. Forgot to screw that down. Let's do that first. Okay, let's try that again. So on. Start game start. Yeah, this is just still not registering button presses anywhere as near good as I would like. So I don't know if that means the switches aren't making good contact or the keyboard scanning on the TMS chip is still just not working 100%. Okay, so the next thing I wanted to try is I want to bend the pins out for RO and R2 because these two are used for the game and the skill select switches. And they're not really strictly necessary for the operation of the unit, that is, if you don't mind it always being stuck in the same setting. But I wanted to try isolating those and potentially wiring those up with a diode to the appropriate K input on this side. So we'll go ahead and get the chip out. Okay, so I have bent out pin RO, and this is used for the game switch, and I was mistaken, it's the skill switch that is hooked up to R9, which is here on pin number 2. So we'll just get our chip back in the socket. With those two pins bent out, and let's see how it behaves. So we'll press start. Yeah, you see the pad's responding much better there. So as soon as I press that button, no doubt about it, it is receiving that input. But it probably needs these to be connected via these switches. It must not have a default state. So let's see if we can connect those with a diode to the appropriate K input and see if that helps it lock in the position of these switches. My thought is that if there's some sort of crosstalk between these outputs and the keyboard scanning, that if we just permanently set these to be bypassed from that circuit, we use a diode going from one of these to the K inputs on this side. Okay, so I've taken two diodes, one in 4148s, and I've wired them from RO and R9 directly to K2 of the TMS chip here. And so I'm just interested to see if we permanently disable our two switches here and feed them an appropriate input, that this may make this work. So let's give this a try. Wow. I don't know if we fixed it, but I really think we may have fixed it. I don't think these switches will have any effect, so if I go ahead and press this again. Wow. This thing is definitely working. I think we may put the cover back on and try this a little bit, and let's see if that really fixed it. Okay, well, so I have the Simon all back together. All the screws are back in, batteries are in, switch covers back on, and I think it's time for a final test, and I'm feeling really good about this now. So we'll go ahead and turn it on, push start. Okay, I'm just gonna get this wrong on purpose. All right. So yeah, Simon is working again. As expected, the game and skill select switches don't do anything, but honestly, I'd rather a Simon game that plays the actual Simon game over it not working at all. And very strange. So yeah, fix it with a couple of diodes. And that was really it. So a lot of investigative work to get there. My best guess is that there is something functionally wrong with the TMS chip. It's either its outputs are dying, its inputs are dying. So it's likely that this unit could fail again in the future, but for now, I think I'm happy to just have a working game. So if you have any ideas on why that might be happening, I'd love to hear it down in the comments. If you enjoy this kind of comments, I'd love it if you subscribed. And I think that'll be it for now, and thanks for watching. Bye!